Okay, today we're going to be talking about Chapter 7-1, which is ratio and proportions. Ratios are just comparing two numbers by division. So you can write a ratio in different ways. You can write 1 to 2, or 1 to 2, or 1 to 2. Okay, so all of these are ratios, just written in different forms. A proportion is an equation starting with two ratios that are equal. So, like this, A over B equals C over D. A and D are called the extremes. And B and D, well, B and C are means. Okay. So when you have a proportion that way, you would cross multiply. So you would do A times D and B times C. Okay. Okay, we're going to do two examples. Example 1. Okay, so then we would cross multiply. So we'd have 2y times 4y. So that'd be 8. Y squared equals 9 times 8, which is 72. Divide by 8. So I'll be left with y squared equals 9. And remember, to get rid of a squared, you do the square root. So y equals the square root of 9, which is 3. Okay, example number 2 would be written like this: x plus 3 divided by 2 equals 4x times 5. So you cross multiply. So you're going to do 5 times x plus 3. So you distribute it. And 2 times 4x. So that's going to give me 5x plus 15 equals 8x. Subtract 5x on both sides. So you're left with 15 equals 3x. Divide by 3. So x equals 5. Okay. Example 3. The ratio of the side lengths of a quadrilateral is 2 to 3 to 5 to 7, and its perimeter is 85. What is the length of the longest side? So realize they're not telling you that the sides are 2, 3, 5, and 7. They're saying proportionally 2 times something, 3 times something, 5 times something, and 7 times something. So they're all, the something has to be the exact same. And remember, when you don't know something, you call it x. So it'd be 2x plus 3x plus 5x plus 7x equals 85. Combine like terms, so 17x equals 85. Divide by 17, so x equals 5. Okay, so they asked for the longest side. So you know when you multiply it times the 7, that will give you the longest side. So 7 times 5 gives you 35. Okay, the second part we're going to talk about today is 7-2, ratios and similar triangles. Similar triangles, we already talked about congruent. Remember, congruent meant all the sides were equal, all the angles were equal. Similar triangles are similar if and only if their corresponding angles are equal. Angles are equal, but the sides are proportional. Sides are proportional. Okay? Angles equal, sides proportional. The similarity ratio is the ratio of the lengths of the corresponding sides of two triangles. For example, on this here, I have, let's look at this side. I have a 15 and a 20. I would take 15 and 20 to see if I have a similarity ratio. I would do 12 and 16. And I would do 6 and 8. Okay, so 15 divided by 20. So that equals 3/4. And then 12 divided by 16, 3/4. And 6 divided by 8, 3/4. So since they all have the same ratio when I divided them, that means the two triangles are similar, and their similarity ratio is 3/4. It has to be all the same for it to be similar. If you have different answers, then they're not similar. The similarity statement is just like the congruent statement. So triangle ABC, so order still does matter, is similar. That symbol is for similar. To A goes with angle F, B goes with angle E, and C goes with angle D. So this one says determine if the following triangles are similar. If so, write their similarity ratio in statement. So to figure out if they're similar, I need to divide the corresponding sides. So the 9 and the 8 will go together. You gotta imagine that. Well, actually the 9 and the 6 go together. I lied. The 9 and the 6 go together. So 9 divided by 6. And that means the 12 goes with the 8. And the 15 goes with the 10. Remember, when I divide it, it has to be the same. So 9 divided by 6, 3/2. 12 divided by 8, is 3/2. And 15 divided by 10 is 3/2. So the ratio is 3/2. And my triangle similarity, I could say triangle RSQ is similar to triangle KJL. And that'd be my answer. Okay, what we have on the back, we'll work on tomorrow in class.